in our last example, we again have two overlapping triangles. The fact that I'm showing you two like this should kind of tell you how seriously I take this particular kind of problem, because I know it can be a big stumbling block. Okay, so let's take a look at the two triangles here. Well, we've got this smaller triangle right here. So let's go ahead and draw that. Looks something like that. Yeah? And the shorter side is -4 plus 4x. The longer side is 27, and the longest side is 36. Okay? You'll notice that I reflected it, but again, no worries so long as we do the same thing to the bigger triangle. I'm going to go ahead and copy this and paste it. Whoops. Okay, so here's the larger triangle. And we're actually going to separate these off a bit in a second, because once we have these two triangles, the original is going to become pretty useless. All right, so what do we got here? We've got the longest side on the bottom, which looks like it's 96. And this longer side here, the side that matches up with 27, this longer side here is 72. And this shorter side here, the one that matches up with -4 plus 4x, is 64. And now that I have that, I'm actually going to take this stuff and I'm going to move it away, and we're going to look at this instead of the other one. So I want you to take a moment, please, right now, pause the video, and see if you can set up this proportion and solve for x yourself. The fact that this is a -4 plus 4x doesn't really make anything any more complicated than we already had. So please do pause and give this a shot yourself. Ready, set, go. So there are lots and lots and lots and lots of ways to do this. Here's how I choose to do it. I'm going to take this side to this side. So I'm going to say 64 divided by -4 plus 4x. That is my multiplier, that is my scale factor, that is my ratio. Then I'm going to take, it doesn't really matter which, I'm going to take this 27 and this 72. I'm choosing those just for the reason that I know that they're both divisible by 9, which will make simplifying easy. So I get 72 over 27. Again, which sides you choose don't matter. Which order you put them in doesn't matter, so long as you are consistent. You'll notice that we've got the large triangle over the small triangle, and we've got the large triangle over the small triangle. That is important. And because these two triangles are similar, we know that these two proportions are equal. Now I'm going to do this cross multiplication algebra one more time, and I will try to really space out my steps so that you can see every one individually. Okay? So we're going to start this way. It doesn't matter whether you start from the top or start from the bottom. 64 times 27. All right, well, I'm going to calculator that. 64 times 27. I got 1,728. And that's going to be equal to, remember that there are these parentheses here, so you have to distribute. -4 times 72 is negative 288, and 4x, or 4, times 72 is positive 288x. So my first step was to multiply top to bottom and bottom to top, and make sure to distribute out. Okay? Now I will do my next step in a different color to make it absolutely clear. I'm solving for x. Right now, I've got this negative 288 and this positive 288 here. If you're ever not sure which thing you're supposed to get rid of first, just remember, order of operations goes parentheses, exponents, multiplication and division happen on the same step, and then addition and subtraction happen on the same step, right? PEMDAS. Most folks who have been through algebra or pre-algebra know about PEMDAS. So we're going to do PEMDAS, except we're going to do it backwards. Since we are undoing the things that are happening to x in order to balance the equation, we are going to do that backwards. So we're going to start with addition and subtraction, and then we're going to do the multiplication or division. So I'm going to add 288 to both sides. Negative 288 plus positive 288 is 0, which is exactly what I wanted. And 1728 plus 288 equals, hey, 2016. I will switch colors again for the last step. Divide by 288. Divide by 288. 288 divided by 288 is 1. And 2016 divided by 288 is 7. So we get x equals 7. I'm going to kind of put lines in between my steps here. There we go. So forget the original diagram. This is the diagram. Okay, so to recap this problem, the first thing we did was we separated the two triangles, we redrew them, and we relabeled them so that we wouldn't get confused. To find our multiplier, we took 64 and divided by negative 4 plus 4x. That wasn't the only way we could have done it, but that was the way I chose to pursue this. We did the same thing with 72 divided by 27. We could have totally used 96 divided by 30, or 36 divided by 96. No, I was right the first time. We totally could have used 96 divided by 36. That also would have worked. We just decided not to. No one way is better than any other. So long as you are consistent, you should get the right answer, which in this case is x equals 7. So now that we've got a lot of experience with this, let's go back to our original problem when we were talking about a pool table. Okay? And let's go ahead and label this pool table. So we know that this length is 1 meter. We know that this total length is 2 meters, or width, I suppose we could call it. But we also know that each of these halves is 1 meter because, again, those pockets here are the midpoints of the sides. Okay? Okay. So we know that this cue ball is positioned 0.25 meters away from the top wall and 0.25 meters from the sidewall. Yeah? That's what the problem says. So here's what we're going to do. Now watch carefully. I'm going to do this slowly. We're going to drop a perpendicular line from the center of the cue ball to the opposite end of the table. And hopefully what you can see here is that we now have two similar triangles. Take a moment and ask yourself, how do we know that these are two similar triangles? Just take a moment, take a second. How do we know that they're two similar triangles? Well, we have, in both of these, angle, angle, which is all we need. So now, let's look at these lengths. And this diagram is going to get really confusing for a second, but then we're going to remove the triangles, and it'll get simple again. Okay? So if this whole top side of the table is 2 meters, and this little chunk here is 0.25 meters, then this side of this big triangle must be 1.75 meters. Okay? We also know that this bottom half of the table here is 1 meter. So what else do we know? Take a look at this side right here, please. The whole side right there. Okay? We've got 0.25 up here. We've got x here. So we need an expression for that side. Well, we know that the entire side is 1 meter, right? The entire width or length or width, whichever, of the table is 1 meter. So these two sides together, the two bottom sides of the triangle, must add up to 0.75 meters for the whole thing to equal 1 meter. So we're going to call this 0.75 minus x. Now again, all three of these added up should equal 1, right? 0.25 plus 0.75 is 1, and then minus x and plus x cancel each other out, so we get 1. So just double checking. So now that we've got this big, confusing, messy diagram, let's extract the triangles and make it look nicer, make it look less intimidating. Here's the small triangle. We know it's a right triangle because the problem says so. Its bottom side is x, and its height is 1 meter. This is the yellow one. Then we have a larger right triangle that has an up and down side of 1.75 meters. Let's keep these separate. And a bottom side of 0.75 minus x. It is also a right triangle. And that is the green highlighted triangle. So now that we have this diagram, the original diagram no longer holds any use for us. We're not even going to look at it because it gets confusing. We're going to use this one. Okay. There are lots, again, of different ways that we could do this. I'm going to go ahead and do 0.75 minus x over 1.75. And I'm going to do x over 1. And again, because we know that the internal proportions of all similar triangles are equal, these two proportions must be equal to each other. Cross multiplication isn't strictly necessary here, but we'll go ahead and practice it anyway. 0.75x times 1 is 0.75x. 1.75x. I don't like where this is going. Ah, I made a mistake. Ha! I'm leaving this in the video because I made a mistake, and I hope that somebody caught it while you were watching, because this is super great and this is important. So I'm going to back up a little bit. Take a second. Actually, this is a good experience. This is a good lesson. Take a second, pause the video, figure out where I went wrong. You should be shouting it at your screen. Take a moment. See if you can figure out where I went wrong. Ready, set, go. So this isn't 0.75x. This is 0.75 minus x. I recognized that I was working my way towards getting an answer that didn't make sense because I've done this a lot of times. But if I had continued through that, I would have gotten x equals 0, and x equals 0 couldn't possibly have been the correct answer. So anyway, that was my mistake. So please don't feel bad when you make mistakes. I know I say it over and over and over again, but mistakes help you learn. Okay, so take 2 from the top. 0.75 minus x times 1 is still 0.75 minus x, and that should equal 1.75x. Okay, now we're doing all right. We're going to add x to both sides. Now remember, that is 1x that we're adding. So we get 0.75 equals, let's see, 1.75x plus 1x would be 2.75x. Okay? And then finally, we will divide both sides by 2.75. And we get x equals 0.75 divided by 2.75. I got 0.27272727. Since we are working with decimals, I assume that Khan Academy on a problem like this would be okay with you rounding to the nearest hundredth or something like that. Now, I want you to notice how I organize my work here. Do you see how my work is more or less in a straight column? This bit's a little bit off to the side, but like here's step 1, here's step 2, here's step 3, here's my conclusion. It makes it much easier for me to pick up on making a mistake if my work is organized nice and neat, as opposed to if it's all over the place like I did in, let's see, not that one, like this problem here. This problem here is much more difficult to parse what's happening. And if I make a mistake, it's much less likely that I will be able to find that mistake, because it takes a lot more brain power to try to figure out what's going on. Which step is this even? Okay? So being organized actually will help you, and it will help me give you partial credit, because it makes it easier for me to see what your thought process was. So going back to the original problem, this ball should be hit approximately 0.28 meters from the bottom side of the pool table in order to perfectly reflect off the wall and into the hole. So, after this review video, you will want to take a look at the following Khan Academy topics. These 3 topics, whose due date has already passed, are essentially this video: solving similar triangles advanced, and using congruence and similarity. This one is particularly important because as of the recording of this video, not a lot of people have done this one. And again, a lot of folks get intimidated by it because they put the triangles in all sorts of weird configurations and positions. But so long as you separate the triangles out, where's my problem? Yeah, as long as you separate the triangles out and label them accurately, this is not a difficult problem. Don't try to work with this diagram. Instead, break it up into this diagram, which will make your life just so much easier. I imagine there will be lots of questions about this during my first office hours, so I'm willing to devote quite a bit of time answering questions about using congruence and similarity. Now, in the next video, we're going to talk about the binomial theorem, and we're going to talk about the Pythagorean theorem. And then we will be just about caught up and ready to get started with new content once spring break is actually over. So for now, be safe, be healthy, stay away from other people. Class dismissed.